what do you mean by an FPGA? Well, my name is Rishi Remju, and welcome to the Backbench Engineering Community, where I make engineering easy for you. So, let us ask ourselves that obvious question. What do you actually mean by the term FPGA? Well, let's find out. So, we know for a fact that when we take a slab of silicon like this, a slab of semiconductor, usually silicon like this, and when we add a lot of millions and millions and millions of transistors onto this slab of semiconductor material, this is what we refer to as an integrated circuit or an IC. So here, let us assume that I take an integrated circuit or an IC. So in the previous set of videos, we saw what you refer to as an ASIC or an application specific integrated circuit. So in the case of an application specific integrated circuit, whatever IC that we are taking, it is designed to perform a particular function. That is, an ASIC is designed to perform a particular function. So let us assume that I am creating an electronic device. So therefore, I take a particular ASIC, and here I design this ASIC to perform the function of an AND gate. So in the case of an AND gate, it takes two inputs like this, and it gives a particular output over here. So here we know the truth table of an AND gate. If it is 0, 0, we get the output as 0. Or if it is 0, 1, we get the output as 0. Or if it is 1, 1, we get the output as 1. So this is an AND gate. So therefore now I have designed an ASIC with the function of an AND gate. And now I am taking this particular ASIC and I am placing it inside whatever electronic device that I have created. But when I now take this particular ASIC and place it here, let's imagine that I now realize that the AND gate, this is not the operation that I want to perform here. Rather, I wanted to perform an OR operation. So now what I have to do is that I have to take this particular ASIC which has an AND gate design, and I have to scrap it and I have to put it in the trash. It's no longer useful for me. And now I have to remanufacture or recreate another completely different ASIC with the function of an OR gate over here. So therefore, I have now remanufactured a different ASIC with the function of an OR gate over here. And now I take this particular ASIC and I place it in my electronic device. So every single time I design an ASIC with a particular function, and if I feel that it has to be changed, I'm left with no other options. I have to take this, I have to put it in the trash, and I have to remanufacture that particular ASIC. But what if this particular function that this particular IC does, what if we can reconfigure this? What if it can be reprogrammable? That is, if I now design an IC that performs an OR operation, what if I can reprogram this particular OR operation to be an AND operation? What if now I can reprogram this particular AND operation to be a NOT operation? So this question of what if aroused to the development of a field programmable gate array. An FPGA is simply the abbreviation for Field Programmable Gate Array. It simply means that it is an integrated circuit or an IC in which the hardware operation that it performs can be reprogrammable. We can reprogram whatever operation or whatever function this particular IC does. This is simply what you refer to as an FPGA. Here, the reprogramming is done with the help of certain hardware descriptive languages like HDL, VHDL, etc. With the help of these hardware descriptive languages, we are giving a particular field, we're giving a particular set of commands with this particular hardware descriptive languages. So with the help of those, we can reprogram this particular IC to perform whatever function that we need. That is simply what is referred to as an FPGA. So here, this was a simple example, but in practical cases, a particular IC is used for the purpose of performing very complex operations. For example, an IC will contain something like an AND gate over here, an AND gate over here, both given to an OR gate over here, which might be given to a NOT gate over here. So here it will have two inputs, here it will have two inputs, and here it will have one output. So let us imagine that now I want to reconfigure this OR gate to perform the function of an AND gate. So this can be done with the help of FPGA. All we have to do is reprogram this to perform as an AND gate with the help of a hardware descriptive language. In simple terms, with the help of a particular field, that is, with the help of a particular instruction or a field that we're giving, with the help of a hardware programmable language, we are programming this particular IC. So now here we have understood the first two letters, that is field and programmable. We have understood that this can be programmable with the help of a particular hardware descriptive language. But what is this gate array? For that, let us dig deeper into the working of this particular FPGA. How can we make an integrated circuit field programmable? So for that, let us expand this particular circuit. So here we have a huge FPGA diagram over here. So the interesting fact about the FPGA is that it consists of a number of blocks referred to as configurable logic blocks or CLBs. It has a CLB over here like this, like this, like this. Here it has a matrix of CLBs or configurable logic blocks. So here each CLB consists of 4 elements. It consists of a D flip-flop, it consists of a full adder, it consists of a multiplexer, and finally it consists of a lookup table. So it consists of these 4 components. So these 4 components are present inside each of these configurable logic blocks, which makes them configurable. And each of these CLBs are connected using a reconfigurable interconnect. Each of these CLBs are connected using a reconfigurable interconnect, which can be configured based on which all CLBs we require to be connected for our particular operation to be performed. And over here we have an input-output block. Here also we have an input-output block. This is to accept or give input and output from this particular FPGA. Then it has a memory over here, a block RAM. It has a memory over here as well. There's also a block RAM. So this is the basic diagram of an FPGA. And in between over here it has certain fixed logic blocks as well. So this thus is simply the diagram of an FPGA. So the main advantage of an FPGA is its function itself. It's reprogrammable. We can reprogram an FPGA to perform whatever function we require it to perform. And it has a very high performance when compared to the standard or the conventional application-specific integrated circuits. And now it has reduced the cost of manufacturing by a huge margin, because every single time we make a logical error, then we just have to reconfigure or reprogram that particular IC to perform whatever function that we want it to perform. We don't have to scrape it off and create or remanufacture another IC for it. This thus simply sums up what you refer to as an FPGA. As simple as that, guys. It is simply an array of CLBs that are connected together and placed in an integrated circuit in such a way that we can reprogram this particular integrated circuit so as to perform whatever hardware operation we require it to perform. As simple as that, guys. I'll write it down. FPGA stands for Field Programmable Gate Arrays. It can be reprogrammed using hardware description language like HDL, VHDL, etc. It consists of an array of CLBs which are connected using a reconfigurable interconnect. And these CLBs, they have four main components, which is a lookup table, a full adder, a multiplexer, and a D flip-flop. And the advantages include the fact that it is reprogrammable. It reduces the cost by a huge margin because it eliminates the need for remanufacturing. It increases the performance, etc. This thus simply sums up what we refer to as an FPGA. As simple as that, guys. There's nothing more to it. So I hope you guys now have a clear understanding of what you refer to as an FPGA. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you guys in the next video. Thank you.